For parallel resonance, we also have something called the tank circuit. This is common in Tesla coil terminology, but when you're studying circuit theory, you will find that the tank circuit is simply something of that only gets discussed in parallel circuits. Even though for Tesla coil practical applications, you're going to find people even call a series LC your tank circuit plus your transformer and all that. But we talk more about it here. So I sub T is your total current in the tank. Tank here is the current through the inductor and the current through the capacitor. So if your Q is greater than or equal to 10, the current through the capacitor is the Q factor of your coil times the current in the tank. Current through both elements. And at resonance, of course, you're going to have the same current going through both elements. I sub C equals I sub L. Or, if your Q is less than 10, then that's right, this card doesn't get into that. So, the total tank current here, well, how do you find this? Your tank current is the current from your current source, because things are in parallel, and I treat it as a current source, minus IR sub S, wherever you're, because remember R sub S equals R sub P in parallel with R sub L P, the resistance of your coil brought down by that earlier formula, where IRS is, well, or you can also think of that as V sub C over RS, because I is V over R. If your Q is higher than 10, then you can just use this formula, V over R, voltage across your capacitor, even, because at resonance it's going to be the same as the voltage across the inductance. So R is the resistor and the source in parallel, and current here, source. So, alright. And getting back that voltage across your capacitor, V sub C is I times Z total parallel of the resonant frequency, IS times source resistor in parallel with the R sub L brought down to R sub P. And the voltage across the capacitor is, if you want to have one single measuring point for a voltage across a parallel resonant circuit, it's best to take it across the capacitor. Remember, capacitors store voltage. So this is really your best measuring point to get voltage across your parallel circuit. That's just another way to look at that formula, which we talked more about earlier, our conversion factor. And total impedance is the total resistance, and parallel with XLP, parallel with X sub C, which cancel at resonance. So again, even for a parallel circuit, as well as for a series circuit, if the resonant condition occurs with the coil and the capacitor, the total impedance is going to be just the amount of DC resistance in your circuits.